Okay, so this is a lesson on the introduction to rates. Now, in sixth grade math, students start seeing more math problems that have to do with rates and constant speeds or certain amounts that remain constant. So, for today's lesson, we're going to introduce the subject, and this goes with the Arizona State Standard. This is our code. Arizona State Standards for Mathematics, 6th grade. Understand the concept of a unit rate, A over B, associated with a ratio A and B, with B not equal to 0. Okay? And use rate language, for example, for every, for each one, per. These are terms that we're going to be using for today's examples in the context of a ratio relationship. So today we're going to be able to see both things, so the rate and ratios, how they relate to one another. But these are kind of like simple questions that students might get, and then we might be able to come up with the rates and ratios of these examples. So this is one example that we're seeing. Jen buys 4 tires for $272. What is the cost for one tire? Okay. So before we get to answering these example questions, let's go over our actual lesson, okay? Okay, so first of all, let's talk about rates. A rate is a measure, quantity, or frequency, typically one measured against some other quantity or measure. So it's basically one thing measured over another measurement. So for example, if we see, let me cover all this so that it doesn't get any confusing. If we see 35 miles per hour, we're measuring two things, okay? 35 miles is going to be covered in 1 hour, okay? So this basically means if something is moving at a speed of 35 miles per hour, no fast or no slower, if it remains that way, in 1 hour, it will cover a distance of 35 miles, okay? So this is pretty much what I mean. 35 miles, which is distance for every hour. This is our rate, okay? So this would be rate. Let me give you an example. So 35 miles per hour. That means that in 1 hour, 35 miles are going to be covered, okay? This is also known as unit rate, okay? If we're measuring something and our unit rate is 35 miles per hour, what if our unit rate doubles and we say, what about 2 hours, okay? In that case, our unit rate gets doubled. So 35 miles per hour, now it's gonna be in 2 hours. So that would be 35 times 2, which would be 70, okay? A unit rate could also be seen as $10 per hour. Maybe you work in a certain place and you want to find out what the pay rate is. Okay, well the unit rate or the pay rate would be that in 1 hour you're making $10. Okay, what if I decide to eat something and it says that for every serving is 200 calories? Well, guess what? If you eat twice as that, that means that because you ate twice of that serving, you would be eating 400 calories. Okay, so these standardized rates here are also known as unit rates. Okay, Mr. Vasquez walks 3 miles per hour. Okay, because Mr. Vasquez is able to walk at a 3 miles for every hour. You know, he's gonna keep that speed going. So in 1 hour, he would be covering a distance of 3 miles. Okay. Unit rates tell you how much or how fast something is happening for every time something else happens. So it tells you that in every hour, it's gonna cover 35 miles. It's telling you that for every hour, you're gonna be earning $10. It's telling you that for every serving of whatever it is that you're eating, you're gonna be eating 200 calories. It's telling you that Mr. Vasquez, because of the way that he walks, that in 1 hour, he's going to be covering 3 miles. These are known as the unit rates, okay? Now, what about the relationship of rate with ratio, okay? They're very much related, and let me show you how it works. So for ratio, Our definition states the quantitative means that you can quantify, that you can count, okay? You can count the relation between two amounts showing the number of times one value contains or is contained within another. Okay, let me simplify this definition for you. So, ratio of miles to hours. Let's figure out the ratio. So if someone tells you, okay, how can you turn this example right here into the ratio? What is the ratio of this? Well, let me show you. The ratio of miles to hours, it would be 35 to 1, okay? It means that in every one, this one is represented for the hours. You would be covering 35 miles. So this is the ratio of 35 miles per hour. Once again, it means that for every 1 hour, you'd be covering this amount in distance. So the ratio of miles to hours of 35 miles per hour would be 35 to 1, okay? Now I made this question so you can think further. What if you travel at 35 miles per hour for 2 hours? Well, take some time right now for you to think about what would be this number. Okay? This would be your answer. If the unit rate is 35 miles per hour, multiply that amount times 2. Okay? So 35 times 2 equals 70, because that was the initial constant speed. Okay, so your ratio would be that for every 2 hours, you would be covering 30 miles. Okay, because 35 times 2 is 70. So our ratio would be 70 to 2. Okay, ratio of miles to hours: 35 miles per hour, 35 to 1. What if you travel for 2 hours? Well, it would be, because you multiply 35 times 2, it would be 70 to 2. Okay? Now, here, these are just some other forms of how you would also see ratios written. So you would see it like this, 70 to 2. You would also see it like this, 70 over 2. And in some cases, you would also see it like this, 70 miles for every 2 hours. Okay? So these are 3 forms of how you would see ratios. Okay? So as you can see, rates and ratios are pretty much related. The key word here is that ratios are quantitative. Ratios are things that you can see in that form of a number. Okay? A rate is basically constant. Okay? 35 miles per hour. If you keep on going at that speed, if you go any faster or any slower, then you would break the rate. Okay? You would be earning $10 per hour. No more or no less, because you would be breaking the rate. Okay? Alright, so let's go back to our initial examples here. And I already did the work for you, but we're going to go over step by step. Okay? So Jen buys 4 tires for $272. What is the cost for 1 tire? Okay? If you want to find the cost for 1 tire, but you know that every 4 tires are being sold for $272, you can divide 272 by 4. And this is pretty much how it would look. So you divide 272 by 4. So 2 goes into 27 6 times, giving you 24. You subtract that, gives you a remainder of 3. You bring down the 2. 4 goes into 32 8 times. 32 and 32. Gives you a remainder of 0 here. And you have 68. This means that each tire is $68 per tire. Okay? If you want to buy 1 tire, it's going to be $68. So this is also known as your unit rate. Okay? So that's unit rate per tire. Okay? You want to buy 1 tire? $68. This is how you answer this question. Okay? Next example. Delilah does 184 jumping jacks in 4 minutes. Okay? She does her jumping jacks at a constant rate. That means that the speed is not going to change. No faster, no slower. Okay? How many jumping jacks can Delilah do per minute? Okay? So once again, divide 184 by 4. There you go. It is 46 times. 4 goes into 18. 4 times gives you 16. You subtract that, remainder of 2, bring down the 4, 24. 4 goes into 24 6 times. 24 minus 24, remainder 0. Okay, so your 46 is going to be your answer. That means that Delilah is going to be performing 46 jumping jacks for every single minute. Okay, this is basically what, because she keeps her speed, her rate the same, every minute it'll be 46 jumping jacks. That's the unit rate per minute. Okay, so that has been our little lesson on for figuring out unit rates and the relation of rates with ratios, with the quantified information of ratios. Okay, our next video is going to go more into in-depth look into rates and ratios. So thank you for this opportunity. Thank you.